Hi friends, so this videos means in this playlist, this course is going to be full about quadrilaterals and their properties and the different types of quadrilaterals. So first let us see what is a quadrilateral. For example, if we keep three collinear points, it is a line segment, and if there are three non-collinear points, it forms a triangle. But what if there are four non-collinear points? Then we will form a four-sided figure which is a quadrilateral. So such a figure formed by four non-collinear points, 4 points in an order, is called a quadrilateral. So there are basically two types of quadrilaterals, concave quadrilaterals and convex quadrilaterals. So now let's see what are concave quadrilaterals and convex quadrilaterals. Quadrilateral is nothing but a closed plane figure. So this is a quadrilateral ABCD. And let this be the quadrilateral PQRS. So the basic rule in naming of quadrilaterals is that the letters must be side by side to each other as in their order. For example, this is the quadrilateral ABCD. So it must be written as A, B, C and D. It can't be written like A, B, C and D. Letters must be in an order A, B, C, D. And here also you can notice that P, Q, R and S, or it must be in the reverse order. It can also be in the reverse order S, R, Q and P. They must not be mixed together. So these are the two types of quadrilaterals. The basic difference between them is that all interior angles in this quadrilateral are less than 180 degrees. So all the quadrilaterals which are having all the angles in them less than 180 degrees, they are convex quadrilaterals. So in this figure you can notice that there are four sides, so it's a quadrilateral, but not all the angles are less than 180 degrees. This is less than 180 degrees, this is less than 180 degrees, this is less than 180 degrees, but this angle is not less than 180 degrees, but it is more than 180 degrees. So all the quadrilaterals which are having the angles more than 180 degrees or 180 degrees are not convex quadrilaterals but concave quadrilaterals. So these are the convex quadrilaterals and these are the concave quadrilaterals. So in this course we will be mainly focusing about the convex quadrilaterals but not about the concave quadrilaterals. In this video we are going to mainly talk about the different types of quadrilaterals, means the convex quadrilaterals, and especially about parallelograms which are quadrilaterals but a different part of them. So all the quadrilaterals have four sides, four angles and four vertices. Let us take this quadrilateral A, B, C, D. This is a quadrilateral ABCD. So all the quadrilaterals have four angles, four sides and four vertices. So all the four sides in this quadrilateral are AB, BC, CD and AD. All the angles are angle A, angle B, angle C and angle D. And all the vertices are A, P, C, and D. So all quadrilaterals have 4 sides, 4 angles and 4 vertices. So, and we all need to know the basic property of a quadrilateral, that is the angle sum property of quadrilateral. So angle sum property of triangle is that the sum of all interior angles of a triangle are 180 degrees. And now for quadrilateral, the angle sum property of quadrilateral is that all the angles of a quadrilateral are 360 degrees. That means the sum of the angles of quadrilaterals are 360 degrees. So first now let us take a quadrilateral ABCD. Quadrilateral may be in any shape, but just they need to be 4 sides, 4 vertices and 4 angles. So this is a quadrilateral ABCD. Now let us prove the angle sum property of the quadrilateral, that the sum of all the angles of a quadrilateral are 360 degrees. That means the sum, what we need to prove is angle A plus angle B plus angle C plus angle D is equal to 360 degrees. This is the angle sum property of quadrilateral. That means the sum of all the angles of a quadrilateral are 360 degrees. So to prove this, let us draw diagonals. Diagonals are nothing but the line joining the two opposite points of the quadrilateral. So for this quadrilateral, the diagonals are AC and BD. It is a diagonal because it is joining the two opposite points of quadrilateral. So diagonals are nothing but the lines which are joining the two opposite points of a quadrilateral. And now to prove the angle sum property of quadrilateral, we need only one diagonal, but I need to just explain. So this is a quadrilateral ABCD having diagonal AC. So now let's prove the angle sum property of the quadrilateral. So we all know that angle sum property of a triangle is 180 degrees. So it must be that angle in triangle ABC. In triangle ABC, let's take only this triangle. Let's not worry about this triangle right now. So in this triangle, the angle sum property which is 180 degrees, that angle A and angle B and angle C must be 180 degrees. So angle A plus angle B plus angle C is equal to 180 degrees. Let's draw this. Let's write in an exponent form. So like angle CAB plus angle ABC plus angle BCA is equal to 180 degrees. Now let's take the before triangle. And now we will erase this triangle. So in this triangle ADC, angle sum property of the triangle is 180 degrees. So angle DAC plus angle ACD plus angle CDA is equal to 180 degrees. This is the equation 1 and this is the equation 2. Now let's add these both equations, which is angle CAB plus angle ABC plus angle BCA plus angle DAC plus angle ACD plus angle CDA is equal to 180 degrees. 180 degrees plus 180. Now let's solve this equation. Now angle CAB. So let's complete the quadrilateral first. Yeah. So angle CAB, which is this CAB, this angle. So angle CAB, and this is angle ABC, ABC, and this angle BCA, BCA, and DAC, and angle ACD, ACD, and this angle CDA. Now let's add these two angles which we have here, angle CAB, and angle DAC, these two. So if we add these two angles, we get angle DAB. So these two angles, angle CAB and angle DAC. So if we add M, we get angle DAB, and this angle is ABC. ABC. We don't have any diagonal here which is dividing this angle into two parts. So there's no way that we can make two angles from this one. So this is a whole angle ABC is a whole angle. So A, B, C, and this angle BCA. BCA, and here this diagonal is dividing the angle into two parts. So let's add this part with the two, so it forms angle BCD. So angle ABC, angle A, angle BCA, and angle DCA are equally, ending is equal, ending is fine. So this angle and this angle means angle ACA plus angle BCA is equal to angle DCB plus angle DCB plus angle, and this angle is remaining. So this is also like D, which is not divided into any parts. So this is also whole angle. So we can write it angle CDA, angle CDA, angle CDA equal to 180 plus 180 is 360. 360. So we have all the angles of this quadrilateral. So angle DAB, let's check if we have all the angles. Angle DAB, this angle ABC, ABC, this angle DCB, DCB, we have this angle, and angle CDA, CDA, we have this angle. So sum of all four angles is equal to 360 degrees. This is how we prove the angles of property of the quadrilateral. And now let's see the different types of quadrilateral. In this video, we basically talk about the angles and property of the triangle and different types of quadrilaterals, and that's it. And in the next video, we will see about different theorems, means theorems of quadrilaterals. Theorems are nothing but things which are explained by giving a proof. The theorems are like sentences. They are in the form like a diagram of parallelogram divides it into two congruent triangles. They just say it, but we don't have the proof, so we have to prove it. Those are solving the theorems. So we'll see about those tomorrow, means in the next video. Now we will see about different types of quadrilaterals. So first, this quadrilateral A, B, C, D, and E, F, G, H, So what are these quadrilaterals? There are roughly 6 types of quadrilaterals, and this is the first one, which is a trapezium. So a quadrilateral having one pair of parallel lines is known as a trapezium. So in this figure, AB and CD are parallel lines. So AB is parallel to CD. So there is only one pair of parallel lines. So this is a trapezium. And in next figure, in this, there are two pairs of parallel lines, which is HG is parallel to EF and GF is parallel to HE. So there are two pairs of parallel lines. So any quadrilateral having two pairs of parallel lines, it is a parallelogram, means the opposite sides of a quadrilateral are parallel. So this is a parallelogram. This is a parallelogram, and this quadrilateral is having one right angle and the opposite sides are equal. So this is a rectangle, and any quadrilateral having opposite sides as equal and all are the right angles. So in this all are the right angles is known as rectangle. So to prove that if a quadrilateral is rectangle, we need to prove that all the angles are right angles and that the opposite sides are equal. So that's how we prove that a quadrilateral is a rectangle. And now we'll take a look at this figure. It may be like this, and this figure are appearing the same without minding their sizes. So in the rhombus, a rhombus is also a parallelogram. Means all the rectangles are parallelograms, but not all the parallelograms are rectangles. Because for parallelogram, there are two pairs of parallel lines, and that is opposite sides are parallel to each other. In a rectangle also there are opposite sides are parallel to each other. But the only difference is that we have all the angles 90 degrees and the opposite sides are equal. But in a parallelogram, the opposite sides are parallel and equal, but not all the angles are 90 degrees. So that's the difference between parallelogram and rectangle. So rectangle can be taken into parallelogram. So all the rectangles are parallelograms, but not all the parallelograms are rectangles. And now let's come to rhombus. So we can identify this as rhombus because all the sides are equal, and the opposite angles are equal in a rhombus. And also opposite sides are parallel to each other and also equal. So the difference between parallelogram and a rhombus is that in the rhombus all the sides are equal, but in a parallelogram opposite sides are only equal. In a rhombus the opposite sides are parallel and equal, but the opposite sides are another pair of opposite sides are also parallel, but they are equal to the other pair of parallel sides.